So we're going to do notes for 11.1 and 11.2. This is surface area of prisms and cylinders. So the first thing we're going to do is get our pen all ready to go. A polyhedron, let's go ahead and define a polyhedron. So it's a three-dimensional figure whose surface area or surfaces are polygons. Three-dimensional figure whose surfaces are polygons. Okay, so any three-dimensional figure whose surfaces are polygons. Okay, this is an example of a polyhedron we have over here. It is a specific kind of polyhedron because it has rectangular sides and bases, and so therefore that gives it a specific kind of name. We'll talk about that in a little bit. But for now, a polyhedron you can think about like a polygon. It's the most generic name for all different sorts of polygons, and we're going to learn specific names for those polyhedrons as we move on. So the face of a polyhedron is each surface of the polyhedron. Each surface of the polyhedron. Okay, each surface of the polyhedron. So a face. I color in this top. That's a face. Okay. And then also, if I maybe choose a different color to make it a little more specific for you, I could color in this side. And that side is also considered a face. And so in this particular figure, we have the top and the bottom. That's two faces. We have the front panel, and then we have the very back panel, and then we have the two side panels. So it has many different faces, okay? So edges. The edges are the segments that are formed by the intersection of two faces. These segments formed by the intersection of two faces. So, an edge. Perhaps we choose green. So this, from this point right down this side, right, that whole side, that's a segment from one piece to the other. I apologize for it being so wiggly. This is a new pen for me, and it's wireless, so it's a little strange. So the edge is the segment from the top all the way down to the bottom, okay? The vertex, we'll go back and get our blue, is the point where three or more edges intersect. Okay, so a vertex is a point. So these are the important words. It's a point. Think about it like a corner. And an edge would be like a fold or a seam. So that would be a segment. Okay, so a corner or a vertex. Okay, so we have the edge, we have the vertex, and then we have the faces. All right, let's move on. So I'm going to scroll the page, I think. I'm going to clear that for you. And let's talk about this example. So it says, name the vertices of the polyhedron. So the thing, of course, that I would like you to try to remember is that the vertices are the points or the corners, right? So we have H, G, D, E, Notice when I listed the corners, I listed them as capital letters and commas between each one of them, okay? Name the edges. So remember that these are edges are segments. Okay, so we're naming the segments. So I'll do these in a different color for you so we try to have them jump out a little bit. So we have this edge, DE, and it's a segment, so we have to put that little segment mark above it. So DE, we have EF, we have GF. Notice I'm going around the base in sort of a pattern, DG. That helps me to not forget any. So then I have the back seam, GH. Then I have this seam over here on the left, that's DH. And then I have this seam in the front, HE. And then I have this HF is my last one. Again, notice capital letters, and we put the little segment symbol above the top. And then the last thing that I have to do is name the faces. So the faces are like the panels or the sides. Okay, the panels or the sides. And so when we name those, we definitely want to try to think about naming those by their shapes. So the bottom is a four-sided figure. So we literally do that. Quadrilateral, D, E, F, G. Notice I went right around the base, D, E, F, G. Okay, all the way around right in order. So that's the bottom. Okay, then I have the sides. So let me get rid of some of this stuff so it makes it a little bit easier for you to see now. We'll get rid of all these colors for now. We'll just be talking about the green one. So remember we had just this bottom one, right? And now I'm going to name the other sides. So the one off here to the left, shape of a triangle, that one. So HGD, so I'm going to go triangle, HDG. Now I know that's really hard to read, so I'm going to trace it over with black for you. So we're talking about that triangular HDG. And we use the little triangle symbol in front, okay? And then we've also got other sides. So we have this front one, HDE, that's also a triangle. So a triangle HDE. So I have the left face, the front face. Now I'm going to do the right face, HFE, that's also a triangle, HFE, and then the triangle in the very back or the back face, which again, really hard to see back there, but HGF, triangle HGF. So panels are sides. We name them. We use the little figure in front to tell what kind of shape it is. That's how we name them. Okay, now let's name this prism. So we're going to clear off the page. And we're going to scroll. And we're going to continue to name the prism. Okay, so first things first, let's name our prism. So we're going to name, we're going to look at the prism and we're going to decide that it's a polyhedron with two parallel faces. Polyhedron with two parallel faces. So two of the faces are parallel. Usually that's top and bottom, but it doesn't have to be top and bottom. It can be, but you can see that this face, the one on the top, is parallel with that face on the bottom, right? If I drew two parallel lines, they would never ever touch, and those two figures, if I just slid them across the page, would always stay at that level and they would never meet each other. They're parallel to each other. Okay, the bases are the two parallel faces of a polyhedron. So a prism is a special kind of polyhedron. It has two parallel faces. So this is a specific kind of prism. So all of these prisms, they kind of look like columns. They can have all different kinds of shapes. We can have a cylindrical prism. We can have this one, which is 2, 4, 5. So it's a pentagonal prism. And we can have a square prism. But the prisms are based on the shape of their bases. That's how we name them. So name by the shape of the bases. So this prism is a polyhedron with 2 parallel sides, and the bases are the 2 parallel sides. They don't always sit on their bases, just so you know. We like them to sit on the top or the bottom on the 2 bases, but they don't always. The lateral faces are the other non-parallel sides. The other non-parallel sides, okay? And the altitude, remember, is always the perpendicular distance between the bases. So it has to form a right angle always, okay? And it is the perpendicular height between the 2 bases. So all of these figures can have what we call the lateral area, and that is the area of just the lateral faces. Okay, lateral faces only. And we do that perimeter times height. That's what that means. Perimeter times height. The surface area is the lateral area, which we just found up here, perimeter times height, plus the area of the 2 bases. And the area formula that you're going to use depends on the shape. Okay, so if the base is a circle, then the area of a circle is pi r squared. If the base is a square, length times width. If it's a pentagon or any other shape, I don't know why there's 2 G's in pentagon. Okay. Pentagon, then it's going to be 1/2 the perimeter times the apothem. So the base area depends on what the shape is. It could be any one of these. All right. So the next video is going to be the next page in your notes, which is going to help you to find the area of these figures.